let's start developing. Today we're gonna be taking on the last day of the 2023 Advent of Code. And usually for the 25th day we only get one part of the task because we kinda get the other star magically because this is the 49th star and we'll need to get the 50th, which means that there is no such thing as a first part and a second part, and whatever hardship we endure, we're gonna endure them in the first part. But the problem is that I read through the problem and we have some kind of a machine that is spread out with lots of interconnected components, and we need to basically remove exactly three branches of that three connections, so to make two separate disconnected groups. Technically, this problem, I've met it before, and this is finding the minimal cut of a graph. And this problem is very much in the NP, non-polynomial group of problems. So it's totally hard to do. But we can start on it, and I have an idea of what to do. So we have this kind of format. I don't think we have any double spaces anywhere, which means that of course we're gonna use regex to see what's inside. So we have our first name, and this is a non-directed graph, which means MMS is connected to NZR and NZR is connected to MMS. Anyway, we have our words. Yeah, we have the start, then we have some words, then we have a colon and a space, and then we have multiple items followed by a space multiple times or no times, and then we have multiple words. So something like that, but I really don't want this group to be capturing since it captures weird things, but I will want this group to be capturing so that we get the thing on the left and we get the thing on the right, and we can just split it using a space. What I want to do, and just a sec, yeah, as I was scrolling, I thought I saw something weird. Yeah, but it's okay, it's just a scrolling artifact. So this is the regex that we're going to use to actually parse our inputs, and I will immediately start with the big input. Yeah, I already have it here. It's 1200 lines. So we read the lines, we have the line regex. Nope, that's not the line regex. Those are the lines themselves. It just doesn't learn that I wanted the other way around. It's gonna be something like this, a key and a value, const notes. I will just call this. I don't want to do too much processing in the actual processing of input. I want just to extract the data, because this data, it's not in a nice format that we will be able to use. We will need to transform it once more, but I will want to basically use that complexity and time inside the part one thing. So for now, we will just have just node input, which will have a name It doesn't have a weight, but it does have a set of children. So if we have the key, we have the value. Otherwise, we throw. So what we need to do here, we need to say return. Well, the name is the key. Yeah, that will work. Value split on each space, and I will just, for sanity's sake, filter only the truthy values. Because if we happen to have a double space, the regex might put it in, and then we have suddenly a none or something like that somewhere. So we're returning the nodes, and we don't have a set of strings. We have a set of node inputs. Not change that, change that, change that, change that. Not those two. Yeah. So let's just console log this to see if we are getting what we're supposed to be getting. 25. The first few are things like these and these. And yeah, we got that. Seems okay, seems okay, seems okay. Seems okay. And what I will now do, I will actually transform this into the dot format for Graphviz. Because one way to do it was basically to take any three nodes. Actually, let's count the nodes. Node input for each, yeah. Let's just see how many nodes there are. We don't need all the input. So, because the problem is that these kind of problems are really hard to do. And there is just no known polynomial solution for this. They have complexities that are like n factorial or e to the n or something like that. And we have 3,383 nodes. So one way we could solve this is by brute forcing it. Literally picking all the possible combinations of three nodes and then checking if that actually splits this thing into something. But how many times will we need to do that? It's basically, yeah, I did that already, but I estimated the task, but it's gonna be this much. So it's gonna be, we're gonna need to choose 3 out of this many, and we have, yeah, about 6 billion combinations. That's not a huge number, but that's not a small number. And for each of that, we will need to analyze if that actually breaks our graph into that. What I will do, I will say we have this tool where we can display something. And I learned of this tool when we did this problem. Come on, update. Yay! So this means that if we have a graph, this thing can visualize it. And here it was totally easy to see what the problem was, so that we were able to implement, I think it was day 21 or 20, but using just some simple math. So I think that the format that we will need to push it is not actually this format, so we cannot just paste this here. So it's not a digraph, it's an undirected graph, but this won't do anything because the format we need is minuses and commas. So we're gonna do that. For each node of input, well, console log, node the name, dash dash, and join everything with a space. Okay, let's see if this thing provides us with any insight, because if I am correct, and so far in this year, it seems that a lot of the problems, maybe because of ChatGPT, are boiling down to actually inspecting and working with the input, not with the example, not with anything. That we need to do some deep analysis on the input, and then for a human, the answer becomes obvious. So let's see this. There's a lot of them. Up to here. NKV to KHC. KHC NKV. So rendering, 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 rendering. Yeah, this is the web version of this tool, so it might take us to something like this, and it says it's out of memory. I will try to fix that. It seems that we kind of broke this tool. I find some other tools, but they don't really support this format, so I will try maybe a different thing. We can just enumerate them for each child of node.children, not child but child, console log node name child. So this is a single a node per line, so we're gonna get 3000 lines. So I will just say write out this into a file. I don't want to scroll through the whole of thing to the console to actually select it. Did we save this? Yep. And now we should get our file with all of its glory. Let's see if you're able to draw this. Not really. And we have this variant as well. I wasn't able to run this locally on my Windows machine. But on the other hand, this should render quite easily. Come on, render. Okay, or so I was able to actually get Graphviz to run locally on my computer, and I got some results. So this is a 5 megabyte PNG, and this is using the dot format. And so this is our graph. You can see there are lots of connections and whatnot and everything, and lots of nodes with lots of things. And I will just keep scrolling and keep scrolling and keep scrolling until we get to this thing. So it seems that there are exactly three lines connecting these two things. So yeah, have two subsets, and those two subsets are connected with exactly three lines. So if we are able to cut those three lines, it would be the resolution we are looking for. However, from this, for the life of me, I cannot determine which of the three lines those are, which nodes they are connecting. I also tried another algorithm which is supposed to be a bit better at this, but you can see we have a very similar picture. We have those two items, and the three connections that are right now here are some of these, I would say. But I have no idea which of them they are. It's not this one, since that connects only upwards. It's not this one, this connects only downwards, but it's some of these. I'm not gonna go through a set. So one way to solve this would be basically to get this and this, a few of these nodes and say, well, try them all. But also what can be seen is that we basically don't have any leaf nodes here. So we don't have any nodes that connect only to one other node. So if we tried to simplify the graph by removing leaf nodes, we will just get nowhere, since these nodes, most of the nodes, I would guess all of the nodes, are nodes that connect to multiple other nodes. Right now I have a third algorithm running that's supposed to be even better than that one. So for example, if I'm running it on a smaller graph, that thing actually gives me something like this. If it works. No, it broke. Let's remove some of that. It might look better. No, still too much. Maybe some more so we can see a better picture. Yeah. So this is giving us the best. We tried this one previously and this one, and you can see that this is kind of okay, but not really. This one is also good. We will try, but we can see that as we go along, we're just kind of connecting. So maybe another approach that we would need to take is to go the other way around, to start building the graphs and see if adding a line actually builds it that way. But that won't be, that will depend kind of that we add our three magic lines at the end of the cycle. And since we don't know which of those are the three magic lines, that's the task actually, we might run into some issues with incorrect, so to say, guesses. And it seems that we got lucky. I graphed this with a few more algorithms and I got this, which is totally unhelpful. And I got this, which kinda does show that we have two distinct sets of points, but I guess these clusters need to be over here and then we will have that. And I did this as well. And here we have kind of a big ball of hair on both sides. And then we have this MVV. Let's look into our input now. So we have MVV, which is connected to some points, but is it connected to XKZ? Yep, it's over here. And seems that this connection is crucial for that. So I will kind of implement some set of code, some code to basically count the cycle. So first of all, we will need to transform this into a proper graph. Which will have basically nodes which are not a node input but just a string array, and we will have edges which are not that but are a tuple of strings. So, or let's do one better. So these are a string array of first, which is a string, and second, which is a string. Note that we have undirected, and this is one thing that I hate about graphs. We have undirected graphs, which means that an edge from the first to the second is the same as the edge from the second to the first. So we will need to write some ugly code that checks if I am first or if I am second. So now we will just transform our input into a graph. So this is node input. And this can be actually a set of strings. And let's do that. Const graph is nodes is a new set and edges in as an empty array. And for each node input of input, we're gonna say, yeah, add that node input to the graph, and for each of the children, also add the child, because there will be some graphs that nodes that don't appear on the left side. And I want to have some kind of a way to determine, yeah, it doesn't really matter. So we can just push all those edges. And those are the nodes and those are the edges. Let's see if this works. Yeah, we counted. This is all the edges actually, not all the nodes. So we have that many nodes and that many actually edges. And we need to cut 3 of the edges. So now I will make some kind of a method. Not console, but something like this. I have no idea if this is correct, but so let's look through it. So we're making an empty array of cycles for each of the nodes. So no, this is not gonna work. Definitely. So what we're gonna do? We need a copy of the graph because I'm gonna want to destroy it. And now we cannot just do this because that means that we will still have the same set, but we will have to say, well, the nodes will be that and the edges will be not even that, but dot, something like this. So we're creating an object that's a copy. Actually, we're not touching the edges themselves, so this might work. Cycles is an empty array. And now we say, while we have edges, while we have nodes, let's take a random node. Do we need a set? Yeah, sure. Something like this. So this basically takes from the values, yeah, takes the first node in any random thing. So we are defining a cycle, and that cycle starts with that nodes. We are deleting that node from the graph. We are saying find me all the edges where that node is in there. So these are the next edges. And this is a queue. So not find, but filter. So all the edges that are in here are part of its cycle. Which by cycle I mean if we have some kind of a separate subset, or yeah, a subset might be a better name, but also cycle is relevant. So we want to find how many nodes are reachable from this node. Are all the nodes reachable? If we have just one cycle as initially put, so that means from any node we can get to any other node. So we're gonna get all the nodes which are attached to that edge. So while q.length is bigger than 0, and now we get the next. And yeah, we need to find the other edge, since the first one is actually our node. Do we want to do that? So this is not going to be a constant because we're going to need to... Oh, this is going to be a pain in the behind. Yeah, maybe we don't want to use a queue. Yeah, take one other. So we will do it one by one. So while there is a next, No, not like that. Or something like this. So we take one node, we remove it from the graph, we find an edge. While we have an edge, we are pushing that other, so we need the other. So this is an edge, and the other is the other edge. So that other edge belongs to the cycle. If it belongs to the cycle, that means we can delete it from the nodes. Yeah, and we are deleting that edge from the edges. And then we find another thing like that. No. Once more, this is incorrect. We will remove everything connected to that, but then we're not gonna backtrack. So, yeah, we're gonna go by the edges. Yeah, our queue will have the edges as well. So until we have nodes, what we're gonna do? We're gonna create a new cycle. Yeah, we're gonna get a new node, and then we're gonna get a new cycle and remove that node from the nodes. But the queue will have the edges. Or maybe the node. So we know for a fact that all these edges belong to the same cycle, since these edges are the edges when this node is used. So we're making a queue of other nodes that have that. So while we have something in the queue, if it's a queue, it's supposed to get from the top. So we're getting a node from that. If we have a node, we are pushing it, we are deleting it, and we are pushing its own neighbors. But we will also need to remove, because this will kind of cycle. So if we have a next, and that next is not already in the cycle, so if the cycle includes next, well, we don't need to worry about that. And at the end, we should get a cycle. So this is a bit weird code, but it might work. Let's see if this actually finishes. Yeah, we don't have that many cycles, that many cycles. In order to have that many cycles, we would have to have, I would say, a graph with no edges at all. Let's debug this. So we have our nodes. Our first node is nkv. We are deleting that, so now we have one node less. And we have some, so what's inside the queue? So this thing is connected to these. So our next is SVC, and I was stupid to include this because it, of course, it will have our graph. No, we need to check something else. Or we can just remove this and say our cycle is a string array. Since otherwise we would add it twice. Let's see how many cycles do we get now. Is it less than 1510? Nope. So back to the debug board. So our queue has those four, as our cycle has nothing. Our node is what? What? Wait a minute. Everything was great. We only missed a exclamation mark. And now we have the correct way. Since all the edges are connected, we have a single cycle. Now I will do what I was thinking to do. So we're gonna remove this edge. And it seems that we have TMT to PNZ as well. Let's see, TMT to PMZ. PM or PN? PNZ. And this thing as well. And we have JBC to XHR or something like that. JBC. Yep, to this one. So I'm gonna remove exactly those three nodes. And let's see what we get now. Two cycles. So those are the three specific nodes that we need to remove in order to get that. And I will also add a bit of this code. No, but just see how long they are. So we have one cycle of 766 and one cycle of 744. And the task was actually requiring of us, let's see, multiplying the sizes of these groups together. So 766, 744. 766 times 744. Now, if this is correct, I won't count this problem as totally solved. But on the other hand, I won't count this problem as totally wrong. That is the right answer. We got the gold star. And let's see what part 2 is. Narrowly avoid a pile of pipes. System overload resolved. Power required is 50 stars. Yep, 1 star fell in, and now all we need to do is to give it 49 stars and then we can restart the system. Unfortunately, we only have 38 so far. And once more, I'm not counting this problem as completely solved, as we kind of solve it by messing up the input and then running it. What we would have to do is to find a way to actually that those are the three that we have to remove. We would have to implement some kind of an algorithm that is similar to whatever produced this image, so that we can somehow group families together, and then it will be obvious that we have these three items that we need to cut. But still, I don't want to implement a whole graphical package just in order to have this specific thing. So we might get back to it, but then again, we might not. Anyway, let's see our calendar. Day 25 is okay. We just need to continue with all the other tasks. So I will continue solving this task even after maybe New Year's when all this is said and done. But so for now, keep developing, mash the buttons, and that's it.